Thank you. Good morning, ladies and gentlemen. And first of all, let me thank you and the whole IIMS for giving us this opportunity to present our presentation. And we heard about the change, a story about change and the advantages and the challenges. And in my presentation, I'll be discussing about another kind of change. That's a change in role of classification from a regulator to innovator of smart and green technologies. You may already know a little bit on the history of classification societies. The scheme of classification started sometime in the second half of the 18th century when a group of marine insurers based in London Coffee House started a process of registering the ships based on an evaluation that is an independent evaluation of vessels and its outfitting. The basic aim was just to decide on the insurance premium of ships which were presented to them for insurance purposes. The system changed in 19th century, that's the early 19th century, when more detailed criteria for evaluation of ships were developed. That's the British Corporation of Register published their first rules in 1834 for survey and classification of vessels. So these are kind of independent standards for survey and classifications, that is independent from the ship owners and the shipbuilders and other stakeholders. And they started the maintenance and development of class rules from 1834. The scheme of classification and the spread to other insurance markets and as well as to other countries as well. And we have now more than 50 organizations which are in the business of ship classifications. But these are the major classification societies are listed here, who are the members of IACS. And together they now handle about 90% of the whole shipping tonnage. So what's the role of class? The role of class is, till now, it was doing their in-house research and development of their rules, and to check that the ship designs are in compliance with those rules. And based on that, the approved plans are developed, and these approved plans are supplied to the shipyards, and shipyards build their ships. And during even the construction of the ships are surveyed to make sure that the ships are built as per the requirements of the class. And in service also, during the operation of ship also, a continuous survey is done in order to see that the ships are kept within the class. And those results are fed back to the research in order to improve the rules. But I have to mention here that being in class does not guarantee the safety or the environment protection of the ships, because class do not cover the entire equipment or the entire ship. So that's where the importance of the marine surveyors has to be highlighted. The entry of force of international conventions changed the game a bit. As you know, the SOLAS came into force in 1914 and followed by international load line conventions, and then the tonnage conventions, MARPOL, and after the turn of the century, we have the anti-fouling system, that is the control of harmful substances in anti-fouling system convention came in 2001, and more recently we are now discussing on the ballast water, implementation of ballast water management convention and ships recycling convention. And also at the ILO side, we have now maritime labor convention. So the role of class has changed since the implementation of these conventions. We have a vast majority of flag states now which delegate their work to classification societies. So classification societies act as recognized organizations during the plan approval, technical surveys of vessels, and issuing the statutory certificates. The organization which I belong to, Class NK, is now a recognized organization of more than 100 flag states. So how this game has changed today? Now classification societies are no more regulators, but they are also innovators. The main reasons, purely economic. The falling charter rates since 2008, the rising bunker prices, falling ship prices or oversupply of ships, which is hurting the shipyards, and the entry into force of new regulations, which is putting additional burden on ship owners. So there is a need of innovation, but the question is, who is going to support the funding of required to do this whole research and development? Our answer is that we have increased our funding for research and development from 8% of our total revenue in 2008 to 16% in 2013. But still, we cannot do all this research by ourselves. We should have a collaboration between owners, shipyards, universities, and different manufacturers. So in 2009, Class NK with all the major other stakeholders developed a joint R&D program, which as of 2013 completed 122 projects, and 93 other projects are going on, and 78 projects are still in planning. And this covers a wide variety of topics on ship safety and environment protection. So these are some of our research partners. We have all the major ship owners based in Japan, and as well as the shipbuilders, and there are equipment manufacturers, and the universities from different parts of the world are involved in this joint project. In my next few slides, I will try to explain some of the results which we achieved from this joint R&D project. So our approach is development of smart IT platforms which are safe and secure, user-friendly, and of low cost, and developing new technologies for eco ships which are eco-friendly, energy saving, and greenhouse gas reducing. So the basic goal is to reduce the cost for all the stakeholders. So one such technology which we have developed is Prime Ship. That's for the direct strength assessment of ships. So this provides a simple and efficient strength assessment system, and to check that the ships are built as per the Class NK rules and IIMS common structural rules, which is so-called the CSR. It has got an extensive data transfer function, which means that the information can be easily exchanged between different stakeholders, and it can handle a wide variety of loading conditions to simulate the actual conditions which the ships goes through during its operation, and also has a very user-friendly interface. So NK is among the first among the classification societies to develop a direct strength assessment software for IIMS harmonized common structural rules. So a bit more detail of the direct strength assessment technology. So it is, Class NK has developed this in collaboration with Altair Engineering using their HyperWorks technology. And as I mentioned earlier, it has an extensive data link function, so that any information which is developed using other CAD functions can be easily imported to our package. And it has a auto meshing function to generate the meshes which is required for detailed finite element analysis. And it has an auto member function, so that the designer can use the technology and define the ship members and that is the scan links, and analyze those scan links. And of course, it has a very good report generator. So as you know, the Ship Recycling Convention, which came into force in fact, it was adopted in 2009, but still yet to come to force. But one of the challenges which the industry is facing in implementation of the Ship Recycling Convention is the development of inventory of hazardous materials. So the manufacturers, how this inventory of hazardous material is made. The shipyards has to collect the information from on the hazardous materials which is contained in each item from the manufacturers in the form of a material declaration. So the shipyard has to compile these material declarations, and at the same time the classification societies has to verify that this inventory of hazardous materials includes the material declarations which we receive from shipyards. And the ship owners, once the ship is delivered to the ship owners, they have to maintain this and update this inventory of hazardous material whenever any equipment is changed or repaired, to make sure that all the details of hazardous materials is included in this inventory. And once the ship goes to the ship recycle yard, the yard has to prepare, that is the ship recycling yard has to prepare a recycling plan, and which is based on this inventory of hazardous material. And the class has to certify that this ship recycling plan reflects the inventory of hazardous materials. So if you try to do this job by hand, so that will be a really difficult, cumbersome task, because even just one hazardous material inventory will have more than 500 to even 2,000 material declarations which are collected from the various suppliers. So it is a huge, the collecting, storing, searching of this data is a really difficult task. And also we have to do a lot of correspondence between the different stakeholders involved. And to store this on board ships or at a place with the ship owner is also a very difficult task. So our solution to this problem is a cloud-based system for ship recycling management. So it's a totally paperless system where the ship manufacturer, the equipment manufacturers, shipyards and ship recycling yards, and as well as the ship owner can input their information directly to this cloud-based system and share the information in a very smooth manner. We have more than 90 shipbuilders and 1,300 suppliers already registered into this system. So this is acts as a one platform for the entire maritime industry to support the Ship Recycling Convention. Another important convention which is coming into force soon is Ballast Water Management Convention. So as per this convention, which we hope will be coming to force soon, all the ships should have a ballast water management system on board in order to meet the requirements of this convention. There are now more than, I think, 60 systems which are already approved by IMO and as well as the flag states, and which are ready to go on board ships. But the main challenge is for the owners here is how these systems are retrofitted into the ships or implemented onto the existing ship structures. Because for all ships, the availability of drawings are limited, and also the measuring going on board the ship and measuring the actual the layout of the different equipments on board ship is really a difficult task, and we need the expertise of different people from different fields, because there are different systems involved on board ships, and the time which is required for the ship on board and the cost involved is also really huge. So our solution to this is 3D laser scanning technology. So how we do this? So the class surveyors, in cooperation with the ship crew or the seafarers, they go on board ships and make a recording of the ship equipment, that's the engine room, for example, and make a record of the group data. And this group data is converted to 3D CAD data, and from there a more detailed a three-dimensional view of the whole engine room, for example, is made. And then based on this information, and as well as with the help of the existing drawings, we can decide on the actual location where we can put this ballast water management system. So this will greatly help in the reduction of ballast water management retrofit time as well as the cost for the ship owner. So another solution which we have is a containerized ballast water management system package, where there is no dry docking required, or there is no major cutting or of the shell plates are required. And by implementing this system, the modification time and cost can be reduced. In this system, the whole package of ballast water management system is incorporated into a container, and then that container is installed into the cargo hold or on board ship if that is acceptable. Yes. Okay. I think I should hurry up. Another challenge which the ship owners and all the people are having is the difficulty in storing the drawings, which will take a huge space, as well as the retrieval of these drawings during the maintenance of the ship is really challenging. And also the IMO goal-based standards, which are coming into force in July 2016, that is almost 1 year from now, require one of their functional requirements is the design transparency, where the shipyards, of course, the intellectual property rights of all the ship design belongs to the shipyard, but they have to share that information with the ship owners, and the ship owners has to maintain those key plans on board ship in the form of a ship construction file. And the basic aim is to help that design information at the design stage in the maintenance of that's the proper maintenance of the ship. So how this can be done without infringing the intellectual property rights of the shipyards and maintaining proper security of these drawings? The solution, again, we have is a cloud archiving system where the owners can directly access to and get the information they needed during the maintenance, and as well as the shipyards and the class societies involved can directly access and get the required information. So we have developed this system in cooperation with IBM technologies. So I'll just briefly touch upon another issue, the issue of cargo liquefaction. I understand there is another presentation coming up, so I'm not going to the details of this. But I just want to introduce the guidelines which Class NK has developed to support the industry to handle this problem of cargo liquefaction. The main feature of these guidelines is, as you can see in table in point 3, the stability and hull strength criteria of the ship which is carrying cargo which is already liquefied. So that is a major input which we give to the industry. And also now we are in cooperation with Rio Tinto Iron Ore Corporation in developing a similar set of guidelines for ships which are carrying iron ore. A brief on the greenhouse gas reduction methodologies, which is under development in Japan. There are various technologies being developed, and it is proved that the efficiency, that is the fuel efficiency, can be improved by application of these technologies. not going to the details of this, but just a quick mention of the Mitsubishi air lubrication system. That is the MALS system, which is applied in some of the ships which are built in Mitsubishi. It's a very simple system where the frictional resistance of the ship hull is reduced by putting the bubble blowers at the bottom of the ship, and which reduces the total area of area of contact between the ship hull and the water, and thus reducing the resistance. And it is proved that this system up to 10% of fuel efficiency can be achieved using this system. And another system is low friction paint, where it's developed with in collaboration with Nippon Paint Corporation, and where they have Nippon Paint has the patent of this technology, where this a smooth surface is obtained by trapping the water in the cavities which is formed by this paint. And we are expecting up to 10% of fuel saving by application of this technology. And just to introduce now classification societies are also involved in floating offshore wind turbine projects. And that is one area which most of the classification societies, including Class NK, is embarking on. So now the real question is how much the owner can benefit from the application of all these technologies. So how can the owner get the real advantage? The solution which we have is performing sea trials on a continuous basis. That is, when the ship is when the sea trial is done at the building stage, and when it goes to the sea and during the operations, we have seen a great difference in the performance of the hull as well as the propeller. But if we can continue this in every 5 to 10 minutes during the entire operation of the ship, and can we use this information in making some progress on the ship maintenance or even the design? So that's one challenge which we are taking upon. So we are collecting information on ships and collecting the performance of the ship's hull and its propeller on a regular basis, and using that information to plan the maintenance in a proactive way instead of doing it in a reactive way. So even this information can be fed back to the ship design, so that the ship owner can make when make a contract with the shipbuilder, he can use this information in developing ships which are of real advantage to him. So our aim is to make a dynamic performance model where the system learns from the actual ship operations and which is continuously improving depending on the actual operation of the vessel. And based on this, we can effectively make use of the new greenhouse gas reduction methodologies and reduce the cost for the ship owner. So what we need to conclude, what we need is a new paradigm that combines the new greenhouse gas technologies and smart IT tools. And in order to evaluate, design, and implement new technologies to provide the real benefits on real ship operations. So with that, I will conclude my presentation. Thank you.
Sounds like there's an awful lot coming up.
Yes.
And that you're being very proactive in your thinking and your approach to owners.
Yes.
Because there's some valuable
Yes.
things coming up there.
Yes.
Very much indeed.
Yes.
Does anybody have any questions?
I have one question. I'm Willem Tambe from Group 7 Consultants.
Yeah.
Dr. Kumar, this question was specifically with regards to the IHM.
Yes.
With the software package that you are mentioning, do we have any historic data
Yes.
that is available for use either on purchase or subscription, where we can have some historic past records of contained or used previously on ships. This is the MDs that you must have collected.
Yes.
Because quite often,
Yeah.
it may so happen that a particular material being used when the ship was built new did not contain the hazardous material. But subsequently, when a spare was provided,
yes.
some material was provided,
Yes.
there was a
It can,
manufacturer who had used that hazardous material. So
Yeah.
do we have that kind of an historic background?
Of course, yes. This is even from the building stage. For each and every material or other equipment which goes on board should have this information. That is, the shipyards need to collect that information from the equipment or the material manufacturer, and they have to store this information in this system. And it's on a continuous basis, and not just during the shipbuilding stage, but also when it goes to the owner, when it goes to the maintenance. That stage also, whenever there is a new equipment or a material comes on board, that material declaration has to be obtained. And the duty of classification societies is to make sure that the material declarations are properly maintained. And whenever an equipment is changed, they have to go on board and check these material declarations are properly available and maintained. And ultimately, when the ship is going to the ship recycle yard, then a recycle plan is to be made based on all those material declarations. So yes, your question about the historical information which is needed, that's very important, and that is one of the basic aim of having such a system, which is available to all the stakeholders.
Yeah. Listen, I'm going to have to call it short there, but thank you very much.
No problem. Yes, thank you.
You are available, I understand, for
Yes, yes.
coffee.
Yeah, of course, yes.
We're going to break now, and I ask you to be back in your seats promptly at 11, so that we can start the second session. But before we do, can we just give a round of applause for all of our speakers this morning?
Thank you.